Hi everyone, Gary and Krishna here. In this video, we'll discuss using VirtualWire to share a single traffic generator between two test devices. If you're unfamiliar with VirtualWire, you probably want to view the video, An Introduction to VirtualWire, before watching this one. There's a link at the end that'll take you to our video library. We're going to demonstrate using VirtualWire to create a three-way link between port 3, 20, and 49 on a VirtualWire switch, connecting the traffic generator to two test devices. You could link more ports together, up to the total amount available, but we wanted to keep things simple for the video. We're also going to use a vFlow to filter the traffic so that each device receives the correct stream. Now, NetVisor vFlow is a Pluribus technology used to define fabric-wide policies for line rate control, for manipulation, and the physical or logical redirection of traffic flows. In this case, we can direct traffic at line rate via multiple options, including VLANs, MAC addresses, IP addresses, layer 4 ports, and by protocol as well. In our demo, we have two streams, represented here in green and blue. The green stream represents 25% of the traffic and is being sent to the test device spine 1. The blue stream represents 75% of the traffic going to the test device spine 2. This capability enables efficient sharing of expensive test tools, resulting in significant cost savings since there's no need to buy additional traffic generators for multiple projects. We've broken the demo into two halves. First, we'll initiate the two traffic streams from the traffic generator. Second, we'll show the VirtualWire link connecting the test devices to the generator, as well as show the vFlows named Stream 1 and Stream 2 that are filtering the traffic from the source port to the appropriate destination ports. Lastly, we'll verify that the traffic filtering is occurring. Now before we start, don't worry about the commands. We'll include them in a slide at the end of the video. Okay, let's get started. In a CLI display, the top row is a VirtualWire switch leaf 2, and the two lower rows are our test devices, spine 1 and spine 2 respectively. At the top on leaf 2, you can see that Krishna has run the switch mode show command, verifying that the switch is in VirtualWire mode. He's also run the port association show command, which displays the VirtualWire link between ports 20 and 49, which lead to our test devices, and port 3, which leads to our traffic generator. So we're starting with the VirtualWire links already created. Next, Krishna will run the vFlow show command. As you can see here, we have two vFlows configured, stream 1, which filters traffic between port 3 and port 20, as well as stream 2, which filters traffic between port 3 and port 49. Now let's jump to our traffic generator. In the pane on the lower right, you can see that we have two streams set up. Note that both source IP addresses are from the traffic generator and that the two destination IPs, 10.0.100.251 and 10.0.200.251, are our test devices. Also note that stream 2 is also transmitting CRC errors. All VirtualWire links are transparent, and we're taking the opportunity to show the errors will be seen as well. Now we'll do a quick check to verify that stream 1 is carrying 75% of the traffic and stream 2 is carrying 25% of the traffic. Jumping back to the CLI, Krishna will run the port stat show command with some qualifiers so that we display information on our three ports every second. Now let's take a closer look at the traffic. In the obits column towards the middle, we're seeing outbound traffic occurring on port 20 in the 36 to 38 megabit range, and on port 49 in the 12 to 13 megabit range. That's about 3 to 1 as we expected. Also, if you notice the IRs column, you can see the inbound CRC errors we configured coming from port 3. Krishna will now run the vFlow stat show command at 1 second intervals. As you can see, we're still around 3 to 1 on the packets, stream 1 versus stream 2. Okay, we'll reissue the port stat show command in the VirtualWire switch. And now we'll also issue it on the test devices, ports 101 on spine 1 and ports 20 on spine 2. Now if you look at the IBITS column on the left, short for inbound bits, we see that spine 1 is receiving roughly 14 megabits per second of traffic, and spine 2 is receiving the balance, around 42-ish megabits per second. Now if you recall from earlier in our demo, we set CRC errors to flow on to spine 1. As expected, VirtualWire is transparently carrying those errors, which we can see in the errors column towards the middle of the screen. And that's it for our demo. As promised earlier in the video, here are the commands we used. For more how-to videos and documentation, please refer to the resources section of the Pluribus Network's website. The QR code on the right will take you there. Thanks for watching.